Hi, everybody. Today we're going to talk about alerting and anomaly detection in OpenSearch. Now, I call this something went wrong because that's generally what happens while you're using these features. So today, let's go over the agenda before we get into everything. We'll talk about the project and who I am and why I'm here today. Then we're going to go into what alerting is, what anomaly detection is, and then finally how you can get involved yourself and contribute to both these features. First off, hi, my name's Kyle. This is what I look like in a normal time. Uh, I have to say that we are in this pandemic and we're doing the best we can. And one of the things that I have dropped is my personal grooming. My barber has gone out of business, and I'm trying not to give myself home haircuts. So I hope when we meet in person, which we will sooner or later, I look like the picture on the screen, not the video that you're seeing right now. Now, I work for AWS as a senior developer advocate for OpenSearch. Now, I was hired originally to work for a project called Open Distro for Elasticsearch, and we'll go into what that is and how it relates to OpenSearch in just a moment. Now, just to give you a little bit of background about myself, I want to give you a small biography. I use a few numbers to do that. So first one is 92. 1992, in fact. That's the year that I really got involved in writing software when I was quite young. And at the time, I was really interested in writing compilers. I thought that was the coolest thing in the world. Instead of riding my bike and like doing something that a normal middle schooler would do, I was super into that. And I remember getting every book from the library about it, and I actually wrote a compiler around that time. I haven't been able to find it. I released it as shareware. I haven't heard that term in a long time. So this is something that I've been doing. It's been near and dear to my heart for the majority of my life. Now, 241, maybe 242, depending on what day this comes out. Those are the number of days I have worked for AWS. So I'm relatively new to Amazon. I came from a various background of software development, and I'm glad to be. It's actually a super exciting time for this project and to join that just 241 days ago. It seems like it was a lifetime ago. Um, Three is the number of search engines that I've worked with in my career. I maintained a search engine for Redis first, and then I worked on Redis Search, which is another search engine that's out there, and people have associated me with that in the past. And now I work with OpenSearch. That's kind of my progression over time. Search is kind of one of the domains that I find very interesting. We'll talk a little bit more about that in this session and in other sessions as well. 53. 53 is the parallel at which I live at, so 53 north. I live in Edmonton, Alberta, Canada, which is the northernmost city in Canada. And yes, it's cold as you might imagine by me saying that. It gets to negative 40 in the winter, but we have marvelous summers, and I suggest everybody visit if you would like a nice, cool, and sunny summer vacation spot. Now, 8. 8 pounds is the number, eight represents the number of pounds my dog weighs. You may hear him in the background. He's in a small Italian Greyhound named Mr. Button. I brag about him on social media, the whole deal. So that's a little bit about me, and hope you get a little bit of background on who I am and help make sense as we go through this particular presentation. So let's talk about the OpenSearch project. Now, I want to go kind of into the formal definitions of what OpenSearch is, and we'll move from there. Now, OpenSearch, and I'll read this verbatim. I don't normally read things verbatim from slides, but you'll find this definition throughout the materials on OpenSearch. It's a community-driven, open-source search and analytics suite derived from the Apache 2.0 licensed Elasticsearch 7.10.2 and Kibana 7.10.2. It consists of a search engine daemon, OpenSearch, a visualization and user interface, OpenSearch Dashboards, as well as a series of functionality adding tools and plugins. Now, to go into the history of that a little bit, like I said, I was hired to work on a project called Open Distro for Elasticsearch. And Open Distro for Elasticsearch was taking the open source versions of Elasticsearch and Kibana and adding in a number of kind of really interesting table stakes features. Now, earlier this year, Elasticsearch and Kibana went through a license change where they were no longer an open source license. What Amazon did is they basically took the Apache 2.0 licensed versions, the last one, 7.10.2 of both Kibana and Elasticsearch, and painstakingly went through and removed any mixed licensing that was in the those repos, because there was some different licenses in there that were not Apache 2. Removed any kind of specific build tools that were in there, any type of telemetry, any type of anything in there that tied it back to the original project, and created a clean place to move forward. And that is what OpenSearch is. In OpenSearch Dashboards as well, derived from Percona. So you take those two things together, that kind of forked process, and then combine it with the open distro tools and plugins, and you have the OpenSearch project. Now, what is OpenSearch intended for? It's intended for logs, metrics, and trace analytics, as well as enterprise and general search. Now, looking at the actual title of it, OpenSearch, you might think that, oh gosh, this is just about finding data and indices. But in fact, if you look at the people and how they use it, most people tend to use it for log, metric, and kind of trace analytic use cases. So analytical pieces, but there's still a sizable number of people that use it for enterprise search and general search. It works great for both. When we look at volume, the size of search workloads are much smaller. So by volume, by far, we understand that people use this for logs, metrics, and trace, and kind of these more use cases that don't involve kind of just straight search. Now, I mentioned this a little bit earlier, but I think it's important. The license for OpenSearch is Apache License Version 2, ALV2, as we like to call it, and allows you to use, modify, extend, embed, monetize, resell, or make part of your own product or service. And we think that's really important. Open source licenses, there's a lot of them out there. Some of them have some qualities to them that make some organizations not want to use them. So in our case, Apache License Version 2, ALV2, provides kind of the best of most worlds and makes it really usable in both commercial and completely open source projects without any type of onerous levels to go to of like contributing code back or anything like that for whatever reason. It enables you to do all these different things with it. It's a really great license, and the whole thing is licensed this way, with the exception of one thing, and that's our website, which is open source as well. It's BSD3 clause, and there's a whole story behind that. But that's also a very permissive license as well. So these are super important to us. At Amazon, we have a certain number of licenses that we are allowed to use, and I know a lot of organizations are also like this. An Apache license is one that is pretty widely accepted. Now, the status of this. So we're not generally available yet. In fact, by the time you're watching this, we'll have beta 1 out. In April, we had our introduction and an alpha that was available with no artifacts. You could build it yourself. Beta 2 include artifacts, or beta 1 include artifacts. We'll move through beta 2 and release candidate into general availability in the summer of 2021. So that gives us a little bit of room, as you can imagine, just saying summer. Oh, and by the way, that we mean North American summer, or excuse me, Northern Hemisphere summer. So our folks in Australia or New Zealand, or so let's say South America or Africa, that would be your winter. So let's talk a little bit about more specifically OpenSearch. It's a distributed search engine, David. So it sits in the background. It's not something that you actively interact with if you are a user of it. You interact with it via something like a REST API. So straightforward sending, you have your HTTP verbs, which inform what each operation will do, and you send along some JSON payload with it. It performs the indexing and storage of data. You can index the data to basically be able to retrieve where the data lies. So that's what it's really used for. That's what it's really excellent at. Storage is there as well. It's not a database. Some other sessions will get into why it's not, or why it is and why it looks like it. It's built in Java using Lucene. And Lucene is the kind of underlying library that powers a lot of different things, in fact. But it is kind of where a lot of the search comes from. And Lucene's been around forever. It's been around, I think, for getting on multiple decades at this point. It's really powerful and has a really active contributor base. So OpenSearch owes a lot to Lucene. It's open source as well, by the way. OpenSearch Dashboards is a browser-based UI and visualization tool for OpenSearch. So if you're interacting with OpenSearch, you're actually interacting with OpenSearch Dashboards. It has built-in charts and table representation that you can actually modify yourself or create your own. You can compose those charts and tables into dashboards, which provides that kind of at-a-glance view that most people really want to see. And then you can interact directly with OpenSearch using the REST API that's available, or using DQL. A DQL is the query language that kind of boils down a lot of the REST APIs based on JSON. DQL kind of simplifies that to just quickly get to the data that you need to find. And it's built in TypeScript, so it kind of is a different runtime. It's using Node.js as the runtime. And so they're really kind of two distinct projects that different developers work on, but they work together. So now let's talk a little bit about kind of the meat and potatoes of this particular presentation, and that's alerting. Now, before we go into alerting, let's talk a little bit about what logging is. I have a super simplified version of logging here. So a couple things I want to point out. In the kind of leftmost column, you have the time, and that's of course linear. As we go down, it goes further in time. And then we have these JSON pieces, and each one of these represents kind of like a log line. And in this case, we're looking at infrastructure. So we have an ID for the infrastructure we're monitoring. This is just made up example, but we'll see what we can do with it later. And we have a CPU value. This is maybe like what percentage it's being used. So from 0 to 1, representing kind of like a percentage. So 0.91 would be 91%. And then we have free, and we're just going to use disk space for this example. It could be anything. It could be memory. It could be different types of things that you might want to monitor on your system. And as you can see, we're actually monitoring two different pieces of infrastructure here, identified by that ID. So you have A0B1 as one piece of infrastructure, and then C2B9. This is just made up, so no relevance here. So let's think about this and maybe how you might take this and then take action on it, or be made aware of different pieces that occur here. So in this case, let's take a look at the CPU saturation or the CPU usage, right? So you're at 98% on that. Maybe you might want to say, okay, that means that I'm overutilizing my my CPU here, and so maybe you want to take action on it. The opposite example is also true. So in this case, you're at 1%. So you're underutilizing something. Maybe you have just kind of wasting infrastructure. Then you have, as an example in this, you're the number of space free. Maybe you have 1 GB left and that's not enough. So you need to provision more disk space for whatever infrastructure you're using. And then the other thing to look at is, hey, is something not there anymore, right? So in that case, something's happened and it's no longer responsive. It's dead. I hope you like my little representation of a ghost here. But this is not limited to this use case. You might have other types of logs that would look at feature use. So for example, are people really using a feature that you want to determine if you should invest more time in developing? Are people not using a feature because it's hard to use or something like this? So logs can store this type of data as well. You can look at application performance monitoring. So again, you can say to the end user, is the application performing well? And it provides you kind of an insight into that. And if everything slows down, for example, you might want to know, because that might be aware of some sort of underlying issue. And then you can also have things like fraud mitigation. So in that case, looking at people, let's say that they're changing their credit card information. If people start changing their credit card information really rapidly, what does that represent? All sorts of different things can go into fraud mitigation, and that's a whole almost industry of different methods to get there. So thinking about this and some of the use cases that you might have, let's revisit our example that we had previously. In that case, we're now taking those logs, and then each log line is becoming a document that we're storing in an index. And that's where this comes into the search realm. So if you start thinking about documents as more of kind of like a literal document that we think about, a chapter in a book or a legal document or something, you start to see how the parallels and how a search engine makes sense here. Because what you're doing is you're taking some sort of structured piece of that information, and then you're able to boil it down into a document, and then you can do aggregations and search over it. So let's see how alerting plays into this. Now, as an example, we have our data, and we're going to represent this numerically, which we'll get to in a second. And so you can see it's starting to go up, right? So if you think about your axes in a chart, like a line chart, this is what we're looking at right now. So you can see it's going up, and whatever thing we're measuring, the first thing we want to think of when we're thinking about alerting is setting up a trigger. And a trigger is basically when something hits to a certain level, when are we taking action or doing something about it, right? And you can think of this as previously in our examples of like when you're above 98% of the CPU utilization. Now, how do we get to that number? We use monitors for that. And this alerting feature, a monitor is basically a periodic piece of information that's running, and most oftentimes it's some sort of aggregation. So in this case, you could be looking at, what's the average CPU load over every 5 minutes, as an example, or every minute or something along those lines. So we're looking at that. It could also be something like, for example, how many times has the infrastructure checked in, right? Like what's its heartbeat type of thing. And then if we haven't seen it in a while, that falls to 0. We'd have a different type of graph or chart to represent that, but it's the same idea. Now, so far you're creating the monitors and you're creating the trigger. The one thing that you don't create is the alert. The alert is created by the software, and that's where the monitor is reporting a value that exceeds the trigger. So at that point, you're saying something is out of the ordinary, right? So the machine is saying that, and based on your input trigger and your monitor. At that point, you take that alert and then you go to an action. So an action is something you define that says like, here's the kind of content of what we're going to alert. Something happened, right? Like yikes. So you have that right here. Now, you then take that and send it to a destination. Now that might be an email, it might be a webhook, it might be a Slack message. It can be anything that you really want that could be kind of composed into these different pieces. Now the one thing to understand here is that alerts will continually happening, and you can silence an alert so you don't continually get it. So maybe you do want to have, for example, an email sent for every time it exceeds a certain value. When you pick up your phone and go, oh my gosh, I got 500 emails. That's the sort of thing that you would do, and you would silence that alert so you don't have to see it over and over again. And when the value drops back down, the alert would go away even if you didn't silence it. So you can also that helps you kind of manage when things are kind of transient, right? So this is the terminology here can be a little bit confusing, but this is how the alerting system works. You have these really 5 pieces that you're looking at, and then you have alerts on top of that, which is kind of what sets things into motion. So that's alerting. Now, there is another feature out there that people often get confused with, and that's anomaly detection. So let's take a look at that. Anomaly detection is where you're looking for basically data that looks weird. So let's take a look at how that might happen and the differences with alerting. Now, in our previous examples, we had kind of something that was common among all the things we were looking at. They're bounded in some ways. So CPU, for example, you're 0 to 100, right? So that's something that you can measure. In this case, it's represented by a 0 to 1 value with a decimal place in it. But you know that it won't get to 110%. Like that's not something that would truly be possible. Then you have free. So if you hit 0% or 0 bytes free, that is something that is bounded. Like you can never go to negative bytes free, really. And the same thing with, has something been seen? That actually resolves into a binary almost, like it either has or it hasn't been. But if you run it over aggregations in the kind of monitor sense. So these are things that you can easily reason about where your trigger point is, right? It's easy for you to determine these things because there is a bound. Now, there is another set of problems out there that cannot do this, and that's where anomaly detection comes in. So let's take a look at that. Let's say we have this example where we are looking at amperage, power. So how much amps are being drawn from something. Say you have a meter on this, it's some sort of IoT device. Well, this is an interesting problem because amperage is one of those things that if you plug it into the grid, it can continually draw, right? Like there is maybe a limit that's in some sort of circuit breaker or some sort of hardware, but it can continually get bigger and bigger for whatever reason. Now, if you're looking at this from a perspective, at any given point, it's hard to determine what's bad, right? Maybe it's okay that you're drawing more power because you're doing more things. Um, so this is just an example of one way, but if you look at lots of other things have these kind of unbounded problems. So as time goes on, you don't really know where to hit your trigger point. You saw before, we had kind of that very slim slice. Okay, the trigger point seemed rational here, but as data continually grows, it doesn't seem rational. So you don't really know where to go. But maybe it starts to fall and you say, okay, well, that's my trigger point. When I get to that point, maybe that's what it is. But maybe you don't. And if you notice on here, I don't have a legend that's telling you what this represents. And that's kind of important. And one of the problems that you have in a lot of situations, you don't really know what the maximum is. But you do sometimes see something like this. It's a shape. You can clearly see a human looking at this that this is an anomaly. So that's a different problem to solve than what you could really solve with the alerting, given how it works with that kind of set trigger point. So it works using an unsupervised machine learning algorithm called random cut forest. Now, I have read the white paper on random cut forest a few times. I'm not an expert in it. I have a vague idea, but I don't even want to try to get that out to you because I am not an expert in how this algorithm works. But I do know what it produces. And in fact, if you're using anomaly detection, you don't really need to know how the random cut forest algorithm works. But it gives you two different things, the grade and the confidence score. So like, this basically says how big is it and how confident we are this is weird, right? So those two things can be used to determine what that kind of spike is. You create detectors, right? And the detectors basically are things that will be pointed at an index, and you basically point to a timestamp field in your document, and then you run it at an interval, which is very similar to kind of how the monitor worked in the previous example for alerting. So you add features to the detectors, right? And what that will do, you'll kind of run them through an aggregation function. So min, max, average, count, sum. These very basic kind of aggregation features. And then that allows you to put this together into a more clear picture. So we have this all working together. You can see where you could take and say, okay, when I get a high anomaly grade and a high confidence, we can then do something about that, right? That's something we might want to look at. But in this case, if you have that kind of rising data, it would be difficult any other way to say that. So if the new normal happens, for example, because it's unsupervised and continuous, using random cut forest algorithm, that means that it will continuously look at that and be able to adjust to new normals. So it works when you really want to find a spike or a dip. That's kind of one of the big things here. So if your data is continually growing in an average way, the confidence score will be very low, and then grade will be very low. But then when you get to that level and it starts shooting up, that's when those will change, and that really helps you find that. But if your system just kind of is gradually changing, then that wouldn't be registered as a spike or a dip, right? So that kind of plays into this whole expecting a growth reduction over time, right? So if you expect the data to kind of move or undulate, it can be very difficult to set a point that you might have to constantly reevaluate your trigger if you're using just straight through alerting. You don't know what bad looks like. You know that abnormal is bad, that steady state's okay, or small growth is okay, but if you can't expect it, you can't set that trigger point. So anomaly detection is a great solution for that. You just don't want to set manual thresholds. These previous three kind of all go into that, but there's a lot of times where you don't want to set that, especially for a number of different reasons. So it's just something that if you're looking at that and you're going, I don't know, that will cause too many alerts or whatever, this gives you kind of a way of articulating something without saying an exact value. It was once described to me, this whole process, when you need to find a needle of an unknown shape and size in a haystack of an unknown volume, right? And it can go through and evaluate all the hay that's coming through and going, that doesn't look like hay to me, right? And that's kind of what anomaly detection boils down to. Now, let's evaluate how you use it. Now, anomaly detection can work with alerting. So it works as a monitor for alerting in OpenSearch. So you have your trigger based on the confidence and grade of the anomaly. and your alert and all the rest pieces still work the same, but your monitor is basically from anomaly detection. So you can kind of use them hand in hand, and this is a great example. Is when I get a spike in my CPU workload or CPU load, send me an email. That can happen with anomaly detection, but a spike is hard to articulate in a kind of set trigger. You could also do anything for usage. If suddenly everybody is changing their passwords, maybe that represents something. Suddenly there's a lot of missed password attempts, for example. That would be an anomaly. It could lead you to do some sort of action, either that being automated or a human involved with it. So you can use it without it as well. There's lots of value to it. You can look, and this is a screenshot from our documentation, in fact. You can use OpenSearch Dashboards to visualize and kind of look at the data and the confidence. So you can look at this for live or historical data. So how do you do this? Well, you can see here the lives at the top, and that would just be something if you were sitting there kind of looking at it. You can use that, or you can see the history here. So that's two different axes represented in this kind of heat chart almost. You can kind of hover over different things and look at it as the history of things are happening. So it really boils down some of these very complex data into something that's easy to visualize and take action on. Now, I do want to spend a few moments talking about how you can get involved with OpenSearch. Now, this is a general thing, but also if you want to get involved directly with anomaly detection or alerting, they're both open source, and we have people who are contributing to these, and we hope to have more people contribute to them as well. So how do you get involved? Well, GitHub, of course, is a great way to get involved with most open source projects. We have our organization called the OpenSearch Project. And as you can see here, we have the two main repos, which are for OpenSearch and OpenSearch Dashboards. But if you're involved in a lot of the features, which are housed in plugins, you'll want to look more specifically. So in this case, we have anomaly detection and then anomaly detection dashboards plugin. So what that means is we have a, the anomaly detection kind of matches with OpenSearch, and that's the data layer, and that visualization layer is the dashboards plugin. So they're in two different types of software, so we do split that off. Now, getting involved with the project, how do you do that? We have forums that you can get to from opensearch.org, which is our website. We have a blog where we talk about news, and we have a way that you can see all the events that we're having. So great place to go for that. And then we have biweekly community meetings, and I run those, so I do want to just punch those up a little bit. Those are a really great time where we present what's new going on in the community. So that'll be myself and a lot of people from the team, either inside Amazon or out, as well as community members can talk to one another. So we hope to have community meetings in person as the world opens up a little bit more. But for now, this is a really great place that we can have just the whole community come together in kind of a common Zoom and talk about the issues at hand, get help and opinions from others. So that's what I have for today. So thank you so much for your time. I want you to keep in contact with me. You can see everything there that you can find me. And I'm always willing to talk about OpenSearch. So that's all I got for today. I really appreciate the time. Thanks so much.